So today we are going to do section 2.2, which is chapter 2 out of the book. This is actually going to be module 1, lesson 2. And we are talking about subsets and proper subsets. So just a quick review of what we talked about last week. We talked about sets and the beginning of sets, and we looked at sets that were in set builder notation, and we are putting them into roster notation. So some of the questions that you had asked you to show the set using the roster method. We also talked about the cardinal number, which is the number of elements in each set. And then we talked about the elements that were in sets. So we used this E to show that an item was an element of a set, and then this was to show that an item was not an element of a set. So today we're going to be talking about subsets and proper subsets. The definition of a subset is that every element in a set is also an element of a second set. So that means that we have a set, if we represent a set using a circle or using the Venn diagrams, and we have a set that is inside, then that is a subset. And every single number that is inside of this set, that is inside, has to be an element of the second set. The second definition is the proper subset, and it says that if one set is a subset of another and the two sets are not equal. So what exactly does that mean? So let's say that we have this set of numbers 1, 2, and 3, and we want to list all of the subsets and all of the proper subsets. So the subsets, we could do lots of different things. We can have sets of just the single numbers, so just 1 in the set, just 2, and then just 3. We can also have bigger sets with just 2 numbers, 1 and 2. We can have 1 and 3. And then we can also have 2 and 3. And then we can also have the original set, 1, 2, 3. Now, this is a subset. I know it's confusing, but it follows the definition of a subset, that every element in a set is also an element of a second set. So every element that is in this subset is in our original set. And then the last subset that we have is the empty set. So if you look down here at your notations and highlight this very important notation, it says the empty set is a subset of every set. So every time you ask you for a subset of a set, the empty set is going to be a subset of every single set. So we have all of our subsets listed. The only one that is not going to be proper is our original set because it is equal. And the definition of a proper subset is that the two sets are not equal. So this is the only subset that is not proper. All right. We have some notations over here. We have this elongated C with the line under it means that it is a subset. That notation with a slash through it means it's not a subset. And then we have a proper subset is just that elongated C with no line underneath. And then we have some formulas to calculate the number of subsets and then the number of proper subsets. So let's go ahead and look at our exercises. Number 1 says to select if it is a subset or not a subset. So there should be a line underneath here. So we want to see if it is a subset or not a subset. So we have the set of numbers 1, 2, and 5 on the left, and we want to see if this is a subset or not a subset of the numbers 1, 2, 3, 4, 5, 6, and 7. And we can see that all 3 of these numbers are in this set, so this is a subset. On letter B, we have -3, 0, and 3. And we want to know if this is a subset of the set -3, -1, 1, and 3. So since we are missing 0, 0 is not in this set, so that means that this cannot be a subset. Letter C, we have the empty set. And is this a subset of this set of numbers 2, 4, and 6? Yes, it is, because the empty set is a subset of every set. Very important. And then on D, we have the set 2, 4, and 6, and we want to know if that is a subset of the empty set. And that is not. That is not possible because there is nothing in this set. So if we were to list all of the subsets of the empty set, we would only have the empty set. On to list all the subsets. All right, so we have on A, we have the letters T, A, B. So we can do exactly what we did up there where we split it up into these smaller sets with just the letters. We can split it up further with 2 letters, T and A, T and B, and then A, B. And then we can have the original set. And then we can also have the empty set. So you can represent the empty set using the empty brackets, or you can use the null symbol. Don't do both though. And then on B, we have the empty set. And remember what we just talked about up there. The only subset would be itself. Number 3, determine whether it is a subset, proper subset, both, or neither. So let me write out subset, proper subset, both, or neither. So remember, if the sets are equal, then it cannot be proper. So we have the set VCR, and then we have the set VCRS. So this is a subset because every element of this set is in this set. And it is proper because these are not equal. So it can be both a subset and proper. Okay. B, we have 0, 2, 4, 6, 8, and then we have 8, 0, 6, 2, 4 on the right. So one thing that we need to know is that order does not matter. So these 2 sets are actually the same. So we know that it can be a subset, but it cannot be proper since these 2 are the same. So it's only a subset. On C, we have that X is a dog, and we want to know if it can be a subset of X is a cat. And it cannot because these are 2 totally different categories. And then on D, we have the sets W and Y. So these are our conditions. We have that X is between 5 and 12. and then x is between 3 and 17. So if we were to take 5 is less than x is less than 12, and we were to split this up, we would get that x is greater than 5 and x is less than 12. So if x is greater than 5, we are not going to include 5 because 5 is not greater than itself. So we're going to start with 6, go up, 7, 8, 9, 10, 11, and we cannot include 12 because 12 is not less than itself. So W is going to equal this. And then y equals, we have the numbers between 3 and 17. So similar thing, 4, 5, 6, all the way to 16. So we want to know if W can be a subset, proper subset, both, or neither. And it is a subset because all of these numbers in W are inside of Y. And it can be a proper subset because they are not equal. So both. And our last exercise for today is number 4. And we are going to calculate the number of distinct subsets and the number of distinct proper subsets. So let me write out the formula for subsets is 2 to the n. And then for the proper subsets, it is 2 to the n minus 1 because we always have that 1 that is not proper. And n equals the number of elements. So on A, we have the set 2, 4, 6, 8. So n equals 4. So our subsets, we have 2 to the 4th, which gives us 16. For the proper subsets, we have 2 to the 4th minus 1, which gives us 15. Okay. On B, we have that X is a day of the week. There are 7 days of the week, so N equals 7. So our subsets would be 2 to the 7th. Use your calculator, it's 128. And then for proper subsets, it is 2 to the 7th minus 1. We get 127. And then on C, we have our main point is that X is between 2 and 6. So it would be 3, 4, and 5 in our set. So N equals 3. Our subsets is 2 to the 3rd, which is 8. And then the proper subsets is 2 to the 3rd minus 1, which is 7. And that is all for